Hello class, this is our second example in using T formula to solve trigonometric equations. So let's go straight into it. Well, for this, we first must always state that we're going to be using a T substitution of tan on x over 2, or whatever letter we're using. From here, we can start using our other substitutions for sine. Let's do that now. It's going to be 3 outside of 2t all over 1 plus t squared. And for cos, it's going to be negative 2 times 1 minus t squared over 1 plus t squared equals 1. We're going to do a few steps in one go. We're going to first expand this. We're going to get 6t minus 2 plus 2t squared. And by multiplying by this denominator, we're moving it as 1 times this denominator here. So it's going to be 1 plus t squared. Moving all the expressions, all the terms to one side. 2t squared minus t squared. That's just t squared by itself. There's only 1 6t. And negative 2 minus 1. Which leaves us with this expression. You can try factor this, but you'll find that it's rather difficult. So I would tend to try use a quadratic formula for this. So negative 6 plus or minus 36 minus 4 times a times c, but that is going to be positive 12. 36 positive 12 is going to be 48. So I just evaluated the discriminant there in one go. All over 2 times 1, which is 2. We can simplify this third. That's going to be square root 48 is going to be 16 times 3, which is root 4 times root 3, which is, 2 root 3. Okay. Oh, sorry, my apologies. Square root 16 is already 4, so it's 4 root 3. 4 root 3. So t is equal to negative 6 plus or minus 4 root 3 all over 2. Simplifying this further, we get negative 3 plus or minus 2 root 3. These are our solutions for t. However, remember, right at the beginning, we're not solving for t, we need to solve for x. So from this point, we actually need to continue and let's draw a line. Let's bring this back to the top and let's continue from there. Now from here, remember t was tan x over 2. So let's resubstitute that. Negative 3 minus 2 root 3 and tan x over 2 is equal to negative 3 plus 2 root 3. Taking the inverse of these, so tan inverse of negative 3 minus 2 root 3. Now, at this point, it's always good to check if this value is positive or negative. You can probably guess, just looking at it, that it's going to be a negative. We get negative 6.4641. So we're looking for an angle that needs to be in the second or fourth quadrant for whatever answer we get here. So shift tan or inverse tan of this answer gets us negative 81 degrees and 12 minutes. I'm just rounding it to the nearest minute. But this is not in our domain. So instead, I'll look for the equivalent in the first quadrant of that. So that would be something that looks like this, where this angle here is positive 81 degrees and 12 minutes. So let's disregard this for now. Let's just use this as our reference. If that is 81, we need to find the equivalent of it in the second quadrant. So we're going to say that this angle is 81, which means we're looking for this angle here. Well, that angle is 180 minus that angle there. And for the fourth quadrant, see, so negative 81 degrees is traveling this way in a clockwise direction. We need to find the equivalent angle that travels in this direction. Well, if this angle is 81 degrees 12 minutes, the green angle is 360 minus that answer there. So that angle in green is going to be 360 minus 81 degrees and 12 minutes. So let's leave that for now. Let's solve for this angle here first. I'm going to make the presumption that this is going to be positive, but let's just check just in case. So negative 3 plus 2 root 3 is positive 0.4641. So we're looking for an angle in the first and third quadrant. So if we type this in, so inverse tan of this answer, we already get the first quadrant angle here. So 24 degrees and 54 minutes. That's in quadrant 1. To find quadrant 3, we're looking for 180 plus that angle there. Okay, so our answers that we're looking for, x over 2 is equal to 24 degrees, 54 minutes, that's 1. Here's our second one, 180 minus 81 degrees, 12 minutes. That's 98 degrees, 48 minutes. 360 minus that answer. So we're answering this one now. 278 degrees, 48 minutes. And lastly, 180 plus 24 plus 54 minutes. That's 204, 54 minutes. Just realized it's in the wrong order. Tried getting it in increasing order here. Now we have one last step, because that is x over 2. We want our answers to just be x. So we're going to double all of these answers here. So 24 degrees, 54 minutes times 2. 49 degrees, 48 minutes, that's 1. 98 degrees, 48 minutes times 2. We get 197 degrees, 36 minutes. But now I'm going to state that we don't need to double these two, because our domain stops at x from 0 to 360. Well, if it's only from 0 to 360, if we were to double these two, we would get 400 something for this, which is beyond our domain. And if we double this one, we would get 500 something degrees. So these are our only two solutions for this equation. Now, just to address this one point that I mentioned, we should always test 180 degrees or pi in our equation, because when we use tan, where is it? When we use tan, we might miss that answer, but it might be an answer for this one. So I'll demonstrate to you what I mean. So I'm literally going to type into my calculator 3 sine times 180. Whoops. 180. So I'm just copying this out here. Minus 2 cos times 180. If this does equal 0, then another answer is 180 degrees. So let's check this first. 3 sine 180 minus 2 cos 180. We get 2, which is not equal 1, which is what it should have been. So fortunately for this, we don't need to check 180 as our answer. So that's not part of the solution, but we should still always check. So our only two solutions are these two here. So hope that gave you an insight into using T formula. And yeah, hope to see you in the next video. Best of luck.